Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia for the hyperbolic tangent function. The hyperbolic tangent function accepts an input argument assumed to be in radians and calculates the hyperbolic tangent, which is the ratio of the hyperbolic sine and the hyperbolic cosine. In order to show how this function behaves across a range, I've created a number of values in degrees, and then in column B, converted degrees to radians, and then taken the hyperbolic tangent. And we can see from the graph that as the input values become large, the output of the hyperbolic tangent approaches 1. And part of why that's interesting is that we saw that the hyperbolic sine explodes and the hyperbolic cosine explodes, but when you divide the hyperbolic sine by the hyperbolic cosine, we actually get a well-behaved or reasonably bounded function because the hyperbolic sine and hyperbolic cosine explode at the same rate, which is kind of neat. For very, very small values, or very, very small input values, using my little logarithmic calculator, the output of the hyperbolic tangent approaches 0. And we can see that numerically, for a very, very small positive number, the output is very, very small positive. And for a very, very small negative, we get a very, very small negative output. And that makes sense. As we approach from the left, the value approaches 0 as x approaches 0. And as we approach from the right, the output value approaches 0 from a positive number as the input value approaches 0. For large numbers, unlike hyperbolic sine and hyperbolic cosine, the hyperbolic tangent function is well behaved. For a very, very large input value, we still get well-behaved output values all the way up to 1 times 10 to the 308, which is getting close to the largest number that Excel can represent. However, there is no reason to use a number this large, because reasonably, the hyperbolic tangent approaches 1, or even at values equal to 10. And in fact, if I make this smaller, well, here we can see at minus 360 or minus 2 pi radians, the value is already 0.99999. It's very, very, very close to 1. So if you're dealing with numbers this big using a hyperbolic tangent, you probably don't need to. I think this has some uses in AI and neural network learning, where we want to have values that are bounded into a fixed range between -1 and 1. That's a completely separate video for another time, and probably a different channel. Related functions to the hyperbolic tangent are, as mentioned already, the hyperbolic sine and the hyperbolic cosine. But you could also look at the classic circularly defined tangent function, which is a little bit easier to work with. This concludes the video encyclopedia entry for the hyperbolic tangent function. Please take a moment to like, comment, subscribe if you haven't already done so and want to continue seeing content like this. Thank you for watching.